Questions 27 through 31, we are working with sine and cosine functions, and we're asked to identify the period length. So to find the period length, I'm going to take 2 pi and divide it by b. Now let's look at the generic formula for sine and for cosine. So the generic formula you can see is in the top right corner of this paper, and it's written in blue pen. And so when you see this b value, I'm looking for what is the coefficient of the x. I'm going to take 2 pi for sine and cosine functions and divide it by the absolute value of b. So 2 pi divided by coefficient of 1, 2 pi divided by 1 is 2 pi. That is the period length. That means the length of one cycle. Let's go on to this cosine. The coefficient of the x is 3. That's the b value. So 2 pi divided by the absolute value of 3, and it doesn't reduce, so 2 pi over 3. Now the absolute value of -5 is 5, and it doesn't reduce. This one's a little bit trickier for students. We have 2 pi divided by the absolute value of 1/2. When you divide and you have a fraction on the bottom, you turn division into multiplying, so I'm going to multiply by the reciprocal of the denominator, equaling 4 pi or 4 pi over 1. Let's do the last one together. I have 2 pi divided by the absolute value of 1 equals 2 pi over 1, which is simply 2 pi. Now let's move on, and we're going to look at phase shifts and vertical shifts. Not should. I got to change that for next year. My apologies. Okay, so phase shifts mean when we are horizontally going to take this cycle, this wavelength, and we're going to shift it to the left or to the right. So for these particular problems, I will come up with a value. A phase shift means I'm going to take c and divide it by b. So c and divided by the coefficient of the x, b. And then if it's a negative value, we'd say we do just the opposite. We're going to shift it to the right. If it's a positive, we say shift to the left. Vertical shifts will be the values that are behind often, and they can be written in front, but they are separated by addition or subtraction. Let's get started. So I'm going to identify the c, that's 2 pi, and I'm going to divide it by the coefficient of x, which is 1. So I have pi over 2. Okay, now this represents the phase shift. Because it is positive, then I would describe this as phase shift is left 2 pi units. The vertical shift would be up 4 units. Let's look at number 33. Number 33, a little more difficult. I'm going to take the c value, -pi over 3, and I'm going to divide it by the coefficient of the x. So I'm going to divide this by 2. When I divide, I'm going to turn division into multiplying and take the reciprocal. That's supposed to be a 2, and I get -pi over 6. Now because it is a negative, instead of moving in the direction that would make sense, to the left, a distance of pi over 6, this phase shift would be to the right, pi over 6. Also, there's no value behind that's separated by addition or subtraction, so there's no vertical shift. Let's do number 34. I have pi over 5. I'm going to divide it by the coefficient, so divided by 3 over 1. So pi over 5 times the reciprocal gives us pi over 15. Now because this is a positive value, we do just the opposite. The phase shift is going to be to the left, pi over 15, and we have a vertical shift of down 1. Let's look at 35. I'm going to take a negative, don't forget about the sign, a negative pi, and I want to divide it by 1/3. So negative pi over 1 times 3 over 1, taking the reciprocal of the coefficient on the x, I get -3 pi. So instead of saying to the left, the phase shift would be to the right, a distance of 3 pi. There also is no vertical shift for this problem. Let's go to the last one. Don't forget about the negative. I have pi over 2, and I want to divide it by the coefficient, so we're going to divide by 2. Negative square root of 2 over 1 times 1 over 2 gives us negative square root of 2 over 2. Now it is negative, so we're going to say the phase shift is to the right, a distance of pi over, I keep saying pi, square root of 2 over 2, and we have a vertical shift of up 3/5. If we flip to the next page, we are going to identify the amplitude. Now the amplitude is going to be this value in front of the sign, and we're always going to take the absolute value of it when we identify the amplitude. Okay, so the absolute value of 3 is 3, absolute value of -4 is 4, 1/2, pi, and 12. Let's look at 42 through Right now, when we look at the period length, the phase shift, and the vertical shift, notice that all of the trig functions here are tangents. Now, I did throw in a cosine at the very end to see if I can confuse you. When we find the period length, we're going to do the exact same thing, except for instead of having 2 pi, we only have a distance of pi for tangent. So one cycle here, we're going to take pi and divide it by the absolute value of 2. So this would be pi divided by 2. Now this is the period length. Let's look at the phase shift. The phase shift says take the c and divide it by the b. Now there is no c here. There's no c. So when I look at this particular one, for this particular problem, there is no phase shift because that would be like plus 0, right? So if I take 0 and divide it by 2, I still get 0. So the phase shift does not exist, or 0 phase shift. And there's no additional number in back like a minus 3, so there is also no vertical shift. Let's look at number 43. Let's start right now with looking at what is the length of the period. So I'm going to take pi divided by the coefficient of the x, absolute value of -3. So I have a distance of pi over 3. This is going to be the period length for number 43. What is the phase shift? I'm going to take 2 pi and divide it by -3. So when I simplify that, I would have a -2 pi over 3. Now because it's negative, instead of going to the left, we're going to say shift to the right a distance of 2 pi over 3. And we have this value in back that is separated by addition or subtraction. We're going to shift down 5 for the vertical shift. Let's look at 44. 44, let's start with the period length. So for the period length, I'm going to take pi and then divide it by the value in front. So pi divided by pi gives you 1. So this has a period length of 1 unit. Now let's go with the phase shift. I have -2 divided by pi, so that's -2 over pi. Because it's a negative, I'm going to say shift to the right 2 over pi, and we have a vertical shift of 10. Excuse me. Now let's look at the next problem. On my next problem, I should have added an x here, and I'll let the class know that I should have added an x here behind. So let's start off with what is the period length. I'm going to take pi, I'm going to divide it by 3 over pi. I'm going to write that vertically. Pi over 1 divided by 3 over pi. Okay, that's pi over 1 times pi over 3. Excuse me, so pi squared over 3. That is your period length. Let's look at the phase shift. I'm going to take the c value, and I want to divide it by the b value, which is the coefficient of the x. So divided by 3 over pi. So 5 times pi over 3. So 5 pi over 3. Now because this is a positive value, we're going to say shift to the left 5 pi over 3. And there is no additional value that's being added or subtracted behind, so there is no vertical shift. Now notice we go back to cosines. What is the period length? It's 2 pi for cosine and sine, divided by the absolute value of the coefficient of x. So the period length here is going to be 2 pi over 3, 2 pi over 3. Now the phase shifts, I'm going to take -6 and divide it by the coefficient of x, which is -2. Because it's a negative, I'm going to say shift to the right a distance of 2 units. And lastly, I have a vertical shift of down 2.